a silent design flaw that's killing your ship's speed. Welcome back to Ship's Tech Talk. Get ready to dive into an exciting innovation revolutionizing the maritime industry, the Bulbous Bow. Today, we'll uncover how this remarkable design enhances both the fuel efficiency and speed of cargo vessels. Join us as we explore the fascinating role of the bulbous bow, the science that sets it apart, and the cutting-edge engineering behind its creation. We'll delve into the materials that make it durable and the intricate construction process that brings it to life. But that's not all. We'll examine the various types of ships featuring bulbous bows, discover the perfect size and shape for optimal performance, and even discuss the unexpected colors these bows can sport. And prepare to be amazed by some rare and uncommon facts that will deepen your understanding of this outstanding maritime evolution. Stay with the video for an exhilarating journey into the world of bulbous bows. Bulbous bow. The bulbous bow, also referred to as the bulb or bulb bow, is a protruding bulb-like structure located at the front of a ship just below the waterline. While it might seem like a peculiar addition to the hull, it plays a crucial role in the overall performance of a vessel, especially in terms of fuel efficiency, speed, and stability. This innovation, first widely implemented in the mid-20th century, remains one of the most significant advancements in naval architecture. The role of the bulbous bow. Reduction in wave resistance. The primary purpose of the bulbous bow is to reduce wave resistance. As a ship traverses the water, it creates waves at the bow, resulting in energy loss due to the resistance and drag exerted by the water on the hull. The bulb creates its own wave that interferes with the ship's bow wave, reducing overall wave height and resistance. Improved fuel efficiency. By minimizing wave resistance, the bulbous bow significantly reduces the amount of energy needed to propel the ship. This can lead to fuel savings of up to 15%, especially for large vessels operating at optimal speeds. Enhanced stability. The bulb improves the ship's stability by lowering its center of buoyancy, allowing for smoother movement in rough seas. Increased speed. With reduced drag, the ship can achieve higher speeds without additional fuel consumption. Reduced environmental impact. The fuel savings achieved by a bulbous bow contribute to lower carbon emissions, making it an eco-friendly solution in modern shipping. The science behind the bulbous bow. The bulbous bow works on the principle of wave interference. Here's how it functions. When a ship moves, it creates a primary bow wave. The bulb generates a secondary wave that is out of phase with the primary wave. These two waves partially cancel each other out, reducing the energy lost to wave formation. This process is most effective when the ship is traveling at a consistent high speed and when the bulb is precisely designed to match the vessel's hull shape and operating conditions. Design and engineering of the bulbous bow. The design of the bulbous bow is tailored to the specific vessel. Factors such as ship size, speed, displacement, and hull shape are considered during the design process. Naval architects use advanced computational fluid dynamics simulations to model and optimize the bulb's shape and size. Materials used construction of the bulbous bow. Steel. The primary material used for constructing bulbous bows is marine-grade steel, known for its durability and resistance to corrosion. Alloys. High-strength alloys may also be used for added resistance to impact and wear. Special coatings, anti-corrosion, and anti-fouling coatings are applied to prevent rust and marine growth, which could affect efficiency. Construction process. The bulb is built as a separate component and welded onto the ship's hull during construction or retrofitted during dry docking. Reinforcements are added to ensure the bulb can withstand collisions with floating debris, ice, or other underwater obstacles. Final shaping and smoothing are conducted to ensure optimal hydrodynamic performance. Types of ships with bulbous bows. Not all ships are equipped with a bulbous bow. This feature is most beneficial for vessels operating at specific speeds and with large displacements. Common examples include cargo ships, container ships, and bulk carriers benefit significantly from the fuel savings provided by the bulbous bow. Oil tankers, given their large size and frequent long-distance voyages, tankers often use this feature to improve efficiency. Cruise ships for passenger comfort and operational efficiency. Cruise ships employ bulbous bows to reduce drag and enhance stability. Naval vessels, many modern warships and research vessels, are equipped with bulbous bows to optimize speed and maneuverability. Trawlers, long voyages, and fuel costs make the bulbous bow a valuable addition to these ships. Ships that travel at lower speeds, such as small ferries and tugboats, or those with irregular operations, typically do not benefit from a bulbous bow and thus do not have one. Size and shape of the bulbous bow. The size of the bulbous bow depends on the dimensions of the ship. For a large cargo ship, it can be up to 10 meters in length. The size is calculated based on the ship's hydrodynamic profile to ensure maximum efficiency. Shapes can vary and include rounded, oval, or conical designs. The choice of shape depends on the operating speed and the hull design. Color of the bulbous bow. The bulbous bow is typically painted the same color as the hull of the ship. Common colors include red. Most underwater sections of ships, including the bulbous bow, are painted red due to the use of anti-fouling paint, which prevents marine organism growth. Black. Visible parts above the waterline may match the ship's overall color scheme. Rare and uncommon facts about the bulbous bow. Energy efficiency under optimal conditions. The fuel-saving benefits of the bulbous bow are most noticeable when the ship operates at a steady speed, usually 12-15 knots or higher. First use in submarines. The concept of the bulbous bow was initially tested on submarines before being adapted for commercial vessels. Retrofits for existing ships. Older ships can be retrofitted with a bulbous bow during dry docking to improve efficiency. Seasonal maintenance. Ships operating in icy waters often require additional reinforcements or icebreaker-specific bulb designs to prevent damage. Asymmetrical designs. In some advanced vessels, asymmetric bulbous bows are used to counteract the effects of crosswinds and currents. The bulbous bow is a testament to the ingenuity of naval architecture. By leveraging the science of wave interference, this simple yet effective feature has revolutionized the shipping industry. From enhancing fuel efficiency and speed to reducing environmental impact, the bulbous bow is an integral part of modern ship design. Whether you're a maritime professional or a curious enthusiast, understanding the bulbous bow provides a glimpse into the intricate engineering that powers global trade and transportation. If you discover something new today, why not show your support by hitting that like button? It really helps us out and motivates us to keep bringing you great content. Don't miss out on our exciting upcoming videos about ship technology and equipment. Subscribe now and make sure to hit the bell icon so you're always the first to know when we release new content. Join our journey into the fascinating world of maritime innovation. That wraps up today's session. I can't wait to see you in the next video. It's going to be even more exciting.